EST-205. We're talking about options in heating a house. We talked about electricity, and we have two types of means to heat the house using electricity. What are those?
Hydraulic and,
Using electricity.
oh,
Either heat pumps and coil. We talked about hot water. We talked about combustion. Combustion using oil. Combustion using gas. Using wood stoves. We talked about efficiency and how it's very important to know how to define efficiency. You can't just say it's more efficient or just efficient. You have to kind of specify what do you mean by efficiency, what is your output, and what is your input. And we gave the example of condensing boiler. When you go and they say it's 97% efficient, they do not mean combustion efficiency, that's thermal efficiency. So combustion efficiency is how much heat you absorb or you get out of the fuel. So I'll write it down so you have this distinction.
the question, there's combustion and thermal efficiency,
Yeah.
right? So if you're comparing two different systems, like say hot water or forced air, and you find both efficiencies for each one, and could you take the average of the two, compare, and take the higher efficiency between the two, and go with
No,
that
not the
system?
average. Hold on, let me just focus on that. Thermal efficiency. So combustion efficiency, heat.
Theoretical.
Yeah, theoretical. I was going to try. Thermal efficiency. So the first one, combustion efficiency, it ranges between, could be, I don't know, from 0 all the way to 89%. Depending on how much you burn the fuel, 0 if you didn't burn up much, that's 0. But you're going to have lower and lower efficiency, that's combustion. Depending on the air mixture and the heat, and it goes up. When you first turn on the boiler, probably the combustion efficiency is low until it stabilizes. And in theory, it does not go more than, maybe 89, 90 tops. It does not go to 97. That doesn't make sense at all. And here, this varies between 85 all the way to 98%. That's how much we absorb out of what's coming in there. And again, that's very optimistic to have 98%. And depending on how they calculate what being absorbed by the heat. So what was your question?
If I'm comparing two different systems put into a house, and
Okay.
I look at both of their combustion and thermal efficiencies, if I took the average of the two for each one and found one was higher than the other, would I realistically want to go with a higher average?
So for that system, it's not about we're going to compare the boiler itself, the machine that you put in there.
Yeah.
How much is it putting out? Is it gas or oil? And you actually, it should be labeled on it, what is the efficiency. You don't take the average, you just compare which number is higher.
Which number is that?
That's going to be your combustion efficiency.
Okay.
Actually, the combustion is going to be kind of fixed based on how new the boiler is. You're gonna go with the thermal efficiency because that you cannot change. Thermal efficiency and design efficiency, it's based on the heat exchanger in the furnace or the boiler, so it's how they designed it. When it's clean, it's gonna give you this efficiency. For example, your car, when it's brand new, fuel efficiency is high, then it starts to goes down, and then you change the oil, and you have a little bit better efficiency. Then you have a tune-up, and you go back to the original efficiency, but it's not going to be as efficient as a brand new car, right? But if you neglect the maintenance, you don't do any tune-ups, which is changing the spark plugs, the wires, and maybe clean the catalytic converter, the injection, your efficiency will go down over the years. And you will notice that if you have an MPG counter, you will notice that you're putting more gas into the car. And if you also have an MPG counter and you change your oil, the first couple of 1,000 miles, you can notice that the efficiency is much better. Then it starts to go down because the oil gets more viscous and burn. And those over time, over 2 tanks, you can notice that. So same thing with the boiler. When it's brand new, it's going to perform very well, but then it will stabilize, and it will be dependent on how often you clean it and how often you do maintenance on it. And we said with maintenance, you need to care about the fuel income, the air, and the spark. How fast is it light up? So this is efficiency. Yeah.
0 to 90, 89, sir.
That's combustion.
Combustion.
Zero if everything is burning. The better way you burn it is gonna get higher. And if you start burning, that's why when we do combustion testing, you have to wait for at least half an hour for the whole thing to heat up and stabilize. That's when you get the actual combustion efficiency. In the beginning, the boiler is cool, it's not going to burn very well. When it gets hot, it will stabilize and give you the right efficiency. Actually, with some of the new, like this one, combustion tester, you can keep that on and stick it into the vent, the flue pipe, and you will see the combustion comes up until it's stabilized. So you put it from the beginning, it will start at 50, and it goes up to like 87, 89, and it stops in there. So 87, 89 is pretty good. For old boilers, you can let it go with 75. It's not gonna do better than that for combustion, but it gets better and better. The smaller the chamber, the better, because we contain the flame and the heat, and it will burn in a better way.
If you would have a like condensed boiler, for example, that's pretty high efficiency, right?
Not combustion, thermal. Thermal efficiency. It will say 97, 99. It's thermal because they are absorbing all the heat that comes out of the fuel. For non-condensing boiler, you are rejecting air that's around 300 or 400 degrees. In condensing, no, you are absorbing all the heat coming out of the flue pipe, and you are rejecting air at 70 or 60 degrees Fahrenheit. So you absorb most of the heat that you made inside the boiler. So that's when they talk about condensing boiler, thermal efficiency, how much you absorb out of what you burn. What you burn is going to still be around this rate, which is still good, very decent. That's way much better than a car
Basically,
engine.
in condensed boiler, we will absorb everything what we burn.
Yeah, almost.
Like all.
Close, yeah, close. Up to 98, which is pretty good. That's why condensing boilers are very, very efficient. And they save you a lot of gas. I highly recommend if you are doing new install to do condensing boiler. Question?
I'm just curious, do they ever run the water line in through the exhaust? If it was a bigger pipe and it had a coil, would that be, and then it came back down in, that'd be catching it too, right, the heat?
Probably.
Do they do that at all?
I'm not sure about water, but I know they do exchange air back and
That
forth.
would, yeah, I didn't know
But
about
again,
water.
this is a good area of like inventing something.
Inventing something,
Yeah.
if you use a bigger flue pipe,
Yeah.
that cuts, cause you're gonna cut down the
Yeah.
internal diameter. Use
The
a
more you
bigger
can
one.
absorb, the more you absorb out of the heat, the better. You
In
can
and
come up with a lot of
out, yeah.
ideas.
Yeah,
If you come up with ideas to absorb all the heat that comes out of the car and make use out of it, you'll make a really good invention. People like spend a lot of time trying to absorb as much heat as possible from the car, because most of your energy in the car engine is going to heat, which you don't need.
Mhm.
You get some in the cabin to heat the car, but that's it. Other than that, you just make pumping heat into the atmosphere that you're not using. So how to harness this heat and this energy, it's an idea. That's why the efficiency of a combustion engine is low, 35%, not that much. So you have to make use out of it. Okay, so this is efficiency. I hope you can wrap your mind around what is efficiency, what are we talking about, and again, it's a ratio between what you got out of what you put inside the system. So this is an example. If you were to burn 1 gallon, we strive to get close to 138, which is not going to happen. That's in theory how much is in the fuel. There are ways to burn the fuel much better. If you atomize it, if you heat it, you want to get all the heat that's possible theoretically from that fuel. And that depends on many factors such as the burning temperature, supply of air. In this case scenario, it's possible to get 125, which leads to how much efficiency? I'm going to divide 125 over, which is the output, over the input. So that's 90% that I got. That's combustion efficiency. I might have also thermal efficiency at 98. So this system overall, you're going to account for the combustion and you will count for the thermal out of the fuel to see how much efficiency that system has. When we talk about electrical heaters, we said they are around 99% efficient. Meaning I'm going to put kilowatt, I'm going to give the same kilowatts almost in heat. So that's pretty efficient. Heat pumps are efficient, but not as efficient. They go between 85 to 95, depending on the compression ratio, the new compressor's performance, and so on. Okay, so this is also how do you read those energy labels. And we said yesterday, when we are trying to get the cost of how much the boiler will run for the entire year, we look at those energy labels. And it's good to read those fine prints. I'm not sure what label is that. Hold on, let's see. So here it says this is cost. This equipment is it's a refrigerator. So it's claiming that it will cost $78 a year. Say it will cost $67 a year, which is related to the they're making here. Hold on, let's see. Estimated operating cost based on 2007 national average electricity, which is 10 cents per kilowatt hour, which doesn't exist anymore. And also they give you how much hours it's supposed to be running. The fridge is running 24 hours. So again, this cost is only based on this estimation, and this is the number, how many kilowatts hour a year you will gain. So let's be careful when you buy, and by law you're supposed to see what is the AFUE on every boiler before you buy it. Okay, so that's the efficiency that we have in the basement as our heat source. What Chris I think was referring to is our efficiency for taking the heat out of the boiler all the way to the room. That's again up to you, and that's very hard to gauge because again we will. Okay guys, I'm getting really tired of this late show. So let's think about this efficiency. Let's say we made on average 85% in here. By the time it gets to your room and distributed, we gotta lose some in here, right?
Yeah, it could be 5%.
Some in here, and some in over here. So that's also, again, the system efficiency. This is up to you on how much insulation you have on the pipes. And again, eventually you will lose some, but some of them you cannot do without. So now, no matter how much insulation you put, you're still gonna lose some. So you have to account for that, depending on those radiators and how fast they give you hot air coming out. Okay?
But
So-
still, if you're losing some heat from pipe,
Yeah.
you're losing in the house.
In the house, it's okay.
It's
But
basically,
not if you use it in the basement where you don't want it, unless you want to heat the basement relative. But some people, and we'll talk about how much heat you lose in a bare pipe. Maybe you don't want the basement to be freezing cold. You want to be a little bit around 50. So maybe you leave the pipes on, because you want to leave it inside the house. So again, and this is a very good two-pipe system, which if you notice, there is a supply line, goes around all the way to the end, to the last radiator, that's the supply line, and there's a return line. So those radiators are connected in parallel. So each one of them will get the same temperature and the same pressure because they're tapping into the same supply line. If this was connected with one pipe, like this comes here, then the output goes to the pipe again. That's called the series system, which Tracy was talking about before, and it's just easy way to put it. You're gonna save some pipes and elbows and soldering, but it's not efficient at all because the first room will get all the heat, the second one not, and the last one will be almost dead. So try, I think you have this in your book. This is what it looks like to have a supply line that will connect to each one of those radiator to the end. So they all have the same supply. They tap into the same supply, and the return will go into one pipe all the way back to the boiler.
The return line is just like colder water.
Yeah, after it loses heat. So if this dumping colder water to supply line, that's not good.
This would actually be better for the boiler too, considering it's going back.
Yeah.
I'm guessing at a higher temperature than if it were in series,
That's true.
so you don't have to heat it as much.
I think at the end the output is going to be similar, but it's mostly how to balance the temperature in each radiator, so one will not be as hot as the others.
But so like, you know how like it goes like to like 3 different baseboards?
Yeah.
So the first one is obviously gonna have more heat rate.
No, if you notice, the temperature in the supply line is going to be the same,
Relative.
and the pressure is going to be the same. So remember when we talked about resistances in series and resistances in parallel? We said everyone get the same voltage.
Yep.
So the same thing, every radiator is getting the same voltage now. And the flow is the amps. The amps will distribute each one. The resistance is different. However, everyone will get the same pressure and the same temperature. The water coming at 180, and every radiator will get 180. Because this is only taking a portion of it, not the whole thing.
That thing that's in the supply line, that's the circulator.
Okay?
Yeah.
No, that's like expansion tank. Circulator, I think it's, I don't know where if it's here. But it should be a circulator here. So if you take some time to go observe what system you have in your house, that'll make a lot of difference because now you have an eye for the equipment. So what are we talking about here? So this is for hot water systems. What are the advantages for hot water system? The one we saw before. It's a quiet operation, unless you have bubbles in the air. That's when you hear the swoosh sounds every time the pump comes up. It does not stir up the air because it's using natural convection. Very reliable if it's done well in the beginning. Again, that's a very questionable term. Reliable, what do you mean by reliability? And water has better conductivity and heat capacity than air, which means that I can take a lot of heat from the boiler and deliver it to the living space. Meanwhile, the air does not have the same heat capacity, so I have to pump air continuously into the room. Radiators are relatively small and can go around the walls. Again, that also can be an issue because if you put furniture that blocks the radiator, you have lessened the productivity of those radiators. And if you have a big room like this one, and you want to use baseboard radiators, I'm gonna go around the room probably twice to get the heat I require. So it could be a disadvantage and disadvantage. So again, it depends on the situation and how big of space do you have. And probably you notice in a small kitchen or a small bathroom, it's very difficult to put a radiator there. You have limited space. Also in bedrooms, you have limited space. You have a bed, a closet, dresser, etc. So probably you'll be limited by the space underneath the window, and most likely you'll end up blocking the radiator, so it does not function the way it's supposed to. Some disadvantages of hot water, yeah. It's too small? Yeah. There you go. So, disadvantages, leaks can be problematic. That's why you want to make sure that you have good soldering and you test the system before you put water in it. And also, when you change a component, make sure you test the system before you put water in it. And leaks, even though they could be very small, they could be very damaging because it's going to go through your ceiling. Even if it drips one drop a minute, that over time could be an issue. And it's slow acting, relatively. It will take you a while to heat the water to 180. Then you have to wait to circulate the water through the rooms and it will start to dispense into the room. So probably to take 20 minutes or half an hour to start feel the warmth come up. Unlike forced air where you just hit the button and you'll have hot air in 2 minutes. Radiators fins need to be cleaned. We talked about that before, right? And this is some of the maintenance that will require you to have good efficiency. If the fins over here are not cleaned periodically, they will accumulate a lot of stuff. The air circulation is not gonna go very well. And the radiator will not perform. You, again, probably not gonna remember that. Back in the days when you used to have those VA8 engines that produce a lot of heat, and over time, they tell you to flush your system every year, the radiator system. Otherwise, it will get clogged and the car will start to overheat. We don't have these overheating problems now because the engines are smaller. But if you have a V12 or V8, probably they produce a lot of heat and you have to have a huge radiator. It has to be cleaned. And every once in a while, you go and wash your radiator in the car. You go with a brush and take all the bugs out because, again, they block the heat. So, these has to be cleaned periodically, like once a year, depending on the situation, how much dust do you have or animal hair you have. Because if this get clogged, the air is not going to go flow. It's not going to flow around them. And Chris was saying, like, what if it's too much heat? Can I get rid of some? I don't think it's a good idea because it's really hard to put them back.
That's permanent.
You have to cut the pipe and insert them back again. So, what else? It cannot be coupled with a cooling air system. So if you have a heat system that is hot air, forced water, forced hot water, it's not gonna cool. Can we use this for cooling?
Could. You could, it's a condensation.
No,
Yeah?
you can?
Yeah, but not the same.
You gotta have a drain.
What is it called? The system, Bill's gonna talk about it.
Mm.
It's called chiller.
Oh, okay,
Oh,
water
yeah.
chiller?
Yeah, water chillers. So you can run cold water up to 50 degrees in these pipes, and this time they're not gonna be in the bottom, right? That will be, not going to be productive, because again, it's natural convection, so it's gonna be only cold in the bottom. You're gonna put them in the ceiling, or in ducts.
Oh, and that way the cold
Yeah.
water comes
So
out.
building 17, if you ever notice, they don't have, they have chillers to the top building, hopefully Bill will show you, where actually you cool the water to 50 degrees, which is very doable. So chillers evaporate water to cool the water to 50, and the cool water will just drop.
And
Put
do
those
they
in
do
the-
it through coils like that?
Yeah, similar to that.
But,
It looks like big radiators.
but it wouldn't be exactly the same thing because you have to move to the top.
Then again,
Like, let's say like, it's in the bottom, right?
nice and tell.
That's what I'm saying though, but let's say it's in the bottom for heating, then there's no way it could do both at exactly.
No,
the same
no,
time.
no.
That'd be a whole new system, right?
Yeah. Or you can be, also have, it's the same water system, but you're gonna have to switch from top to bottom. And to do that, if you look at building 17 again, they have basement radiators, and they also have top, which is completely chillers. Chillers are very, very efficient for cooling. They use them a lot in Texas and Arizona, but they're good for big buildings, because the system is very involved.
And it's not-
Nobody
A lot of
put a chiller in a
cleaning
house.
With those chiller ones though,
Huh?
that are mounted up high.
Yeah.
A lot of maintenance.
Yeah. If you look at the back room, the one we were supposed to use for ping pong, there are big radiators for chillers. You can see how they're huge, they're as big as this table. And again, the problem happens is, with those ones, actually, is it's a big, intense radiator, and at some point, it froze and it leaked in one of the pipes inside, and it's very tough to weld that. Sorry. So, again, it's very difficult to put a radiator in a small room. that is efficient, so you can use either kickboard or something that's smaller in size. Size sometimes matter in houses because you have really small places or rooms. Heat can damage furniture, so if you are heating air at 160 over time, some furniture cannot take that, especially if it's not designed for to be at that range of temperature. Okay. Radiant floor. So this is again one of the best ways to heat a house, but it's a little bit involved. That and this it's the how can I say, the most common way that uses radiation, not convection. You're actually radiating heat to objects. So it has the advantage that it's not visible. You don't see it. You don't know it's there, but you feel warm. It's quiet. You don't hear anything. Does not stir air. Easy. Does not need cleaning. It has the best profile for heat comfort. So we said before that the best profile for heat is you have very hot temperature at the bottom, around 85, and on the eye level, it should be around 65 or 70. That will be very comfortable. You feel like balanced, and the radiant floor will provide that. It can be easily zoned. Each room has its own valve and one pump is just circulating. The disadvantage is that it's very expensive to install because look at how much piping is involved. And back in the day, this was all copper. So imagine how expensive that is. Now they have alternative materials, and also they have connection all the way to those radiators using PEX. Although I'm not really sure about the reliability of PEX pipes. So far they want those radiators to be made out of copper, because copper has the best conductivity and also very malleable. Also, leaks can be a very, very major repair. If one of them leak for some reason, let's say for example something got dropped on the floor and it was not designed very well and you had a crack, imagine the work that has to be done to fix that. That's why they have to be done in a very secure manner, and you need somebody who has good reputation in installing radiant floor. They charge you a lot because it involves a lot of techniques in the installation. The spacing between those pipes dictate how much heat you get. The water temperature does not exceed 90. It's between 80 and 90, which is not that much. So instead of heating water to 180, we're heating only to 85 and 90. And that'll be enough to heat your entire house. So that's really convenient. And so that also, the amount of heat required in the room can be calculated using the pipe size and also the spacing between those pipes. There's a lot of things to it. We'll learn some of the math behind it, not a lot. But if that's something you want to do, there are some guidelines specialized for radiant floor heating. And still is something very, very common. You probably see them a lot in museums, courtrooms, or big buildings because it's a major installation. And you don't see any vents. You have vents circulate the air, clean the air, but the heat is coming from the floor. It works really good with the concrete floor, ceramic tiles. People want them usually for the bathroom. It's the best thing to do in the bathroom or kitchen because you have ceramic tiles and you don't have a lot of space to put a heater. So it's very, very convenient. Leaks, it's slow acting, but it's something you keep on for the entire season. So because again, it's really not that much heat. And it's furniture placement can be a problem, so you have to think about that. If you're going to heat the floor and you're going to put tables and couches and rugs and stuff, that's not going to be productive to heat the floor. So it's mostly for plain hardwood floor or concrete floor without a lot of furniture. Otherwise, it's going to hold back the heat from coming up.
Certainly, the disadvantage is you really can't. It's really hard to put this in after you have a finished product.
Yeah, it's very difficult. It's not impossible, but it's difficult.
Yeah, because it'll affect all the heights just by that much on the thing.
Yeah.
How would you do it if you already have concrete doors?
If you have concrete property, you're not gonna do it. Or you're gonna chisel through the concrete, you're gonna apply it. I mean, it's just too much. Maybe you have to put a layer. I'm sure there's a way. There's always a way. If you were to cough up the money, there's always a way to put anything in after a month. But it's gonna cost you a lot. It's also easy to put it in the first floor through the basement because the basement does not have any. You go from the bottom of.
Yeah, 1.5 with 3/4 inch
Yeah.
flooring. That's
It is
all you
doable.
add is 1.5 with 3/4 inch flooring.
It is very doable.
I've been researching this.
Yeah. So again, this is a combination of all the stuff we can use with hot water. We can do radiant, auxiliary heating unit, and this is another unit you can run water through it. That's in the wall. So what I'm trying to show here that there are options in radiation. You can have hot water. You can use some of that hot water for radiant, some of that water for baseboard. And I want you to think about that in your project. So probably some of you had small kitchen or small bathroom. Maybe you should go radiant for that section. But you have to remember that the water coming here is 180. So if you're gonna put 180 degrees water in here, that's not gonna be good. People are gonna be tiptoeing around it. So you'll put a thermostatic valve that will dictate the temperature that goes into that loop. Question?
Can you run your boiler at a lower temp?
Yeah, you can.
With those, it's, you know, like,
Yeah.
maybe up to like 120?
You saw the aquastats, right? Have high limit and low limit. You can put the between 120 and 140.
It doesn't hurt the boiler running a cooler.
No, really.
Or could you set it as a priority zone, and then as soon as it hits that temp,
Yeah.
it'll just switch over to the next zone?
You can get so much creativity out of this. So the thing is, like, you can do a lot of combination with this, and we know how you can switch things, give it priority, do a switching relay. This one get to heat first, this one get heat second. You can do that. So now you have the tools to do stuff like that. Forced air system. This is for distribution. So we talk about hot water distribution and radiant floor, and this is for duct system. If you want to have central air, it's the condenser outside going through the heat exchanger here, and this can be coupled also with a furnace in the bottom. And again, you're gonna have to have duct, and same thing that Felipe was saying. So when I have duct system, ideally you want the duct to be some in the bottom and some in the top, to have the least amount of like forced air coming into the room. So in the winter time, you want the hot air to come to the bottom, to rise naturally. And in the summertime, you want the cold air to come from the top. So some central airs do that. They will switch and reverse the intake and outtake. So you want the cold air to come from the top, to drop slowly, so you don't have to blow air very hard. So this is the well-designed system, well-balanced. You don't feel much, you just feel the air drop slowly in the summertime. And in the wintertime, you will feel small amount of air coming from the bottom and rise and exchange. However, in some of the economical houses, you see only one vent, and in the winter it will shoot up air like crazy to mix air up, and that's what makes the difference between a good design and not so good design. Advantages and disadvantages. It can be used for heating and cooling. We said that system can filter and condition the air, meaning you can pick up some particles in the air, you can add humidity, you can dehumidify, and also it's fast acting. As soon as you turn it on, within a few seconds you feel the heat or the cold air. Some people do not like the draft. They complain about it a lot. It's not very comfortable for them. It's not designed, if it's not designed very well, it's going to be very noisy because, again, as we said, you can have registers that's very small. So to compensate for the size, you're gonna shoot up really fast air, and that will stir up that will produce a lot of draft, and it's very uncomfortable. Ductwork is very elaborate. Again, have you seen ductwork being made? Usually it's made in a manufacturer, it's pre-ordered. Somebody has to go and take measurement. They order the duct, and the duct comes and gets installed in pieces. And there's not a lot of sheet metal workers these days. So it's getting really involved. However, there are options when it comes to ducts. You can use the flex duct. You can use foam duct. I will talk about those. And there are some options. But if you want to do the galvanized steel duct, it's going to cost some money. But again, the more you spend on the system, the more balanced and well-made it will be. Probably if you see some duct work from the 60s that's still running, it has done with really good craftsmanship.
What are some problems that could lead to the forced air system?
Why would you
Like,
need it?
what stuff can go wrong?
Well, duct can break, you can grow some stuff in the duct, mold and mildew. It can have blockage, you can break the inducer fan. There's a lot of problems to it, like anything else, require more maintenance than hydronic. Hydronic, you said it, bless you. And you don't have to do a lot of maintenance besides cleaning the fins. With forced air, you have to change the filter every season, sometimes every 3 months.
That's
the filter
easier
gets
than a
plugged.
tune-up.
Huh?
Well, that's easier than a tune-up on a
Yeah.
boiler.
But yeah, you still have to do the tune-up. Unless you have even with heat pumps, actually every year you have to go and check the refrigerant level. Probably Bill will tell you that. It's very important to go and check your refrigerant every year. Make sure you change the drying filter with the compressor. It has to be changed. Top it off and change the filter. It's not that involved.
The filter dryer?
Yeah.
Really, you have to change it every year?
If you do any changes in the system,
Oh,
you
yeah.
have to change it because to prevent water from coming up. So again, our compressors are very expensive. If you don't follow the maintenance instructions, probably it will void the warranty. So this is a very, very small summary of the options you have. I'm sure there's more. And I did post a discussion link about like, okay, go on survey and tell me has been happening, what's new in the system in the area. Like every time I go to the hardware store, I find new advertisement for new boilers, new techniques, new tools. So it's good to be updated and be in touch with the industry. Questions? Good? Okay, thank you.